Okay, hi.
Hello.
Super excited to be here. I hope everyone is still with us. I know it's been a long day, a lot of good talks, but we have another good talk coming ahead of us. I've been chatting with Roberto Freato over the past few minutes, and I can tell you he has a good thing coming right at you. I don't want to do any spoilers. So, Roberto, the stage is yours. Go ahead.
Thank you so much. Here I am. So, thanks to be here. I'm Rob. You can call me Rob, and you can find this presentation after the delivery on GitHub. So, if you want to reach me out, you can get me there. I've been a freelance for my entire life, but in the last 4 years, I joined with Taylor as the CTO, full-time CTO, and we work on data. Okay, we work on big data. So I switched from my natural origin. I used to be a developer, so now I write a few lines of code yet, but I still love it. And now I'm dealing with big data, data movement, data transformation, analytics, and so on. And why this session? Because I learned during last years that when you have a stable ecosystem, okay, a stable ecosystem in terms of cloud computing, you can even take something off and balance your workload between on-premises, bare metal, multi-cloud, and so on. And you can do this. You can save some money. I don't think it's better in general terms, but it's something that we will dig into this session. Okay, so I just want to make some assumption. I use some prices in this presentation. I have under the hood some calculation methods of these prices, so I can provide some references on Excel. So if you are interested into, but they are indicatives. Okay, uh, please take it as indications. Okay, and I'm not affiliated with any cloud hosting provider. Yes, I'm an Azure MVP. I love Azure. I love Microsoft from the beginning of Azure. Okay, even before, but in this session I want to be strictly connected to a cloud provider. And sorry about my usage of hybrid buzzwords. I mean everything about hybrid that is not public cloud. Okay, so pardon for this. So let's start with a question. Unfortunately, we are in a virtual stage, so I cannot ask you to raise your hands. Okay, but the question here is: do we know in this case what, how much is a core today? The cost of the core. I mean, in the public cloud. Okay, in mainstream public cloud. I make some proxies around this question, and I found out that $30 per month can be a good proxy. Okay, I tried to take the same processor type, the same machine type, and take this value from the single core. Okay, splitting the single core, and this can be a good proxy. Okay, this stands for major public clouds. So for major, I think the three, four big ones. Okay, but if you can go to the cheap ones, okay, we have some. We probably know some cheap hosting provider that are also cloud providers. The price can be lower. Okay, and if we go down to the bare metal managed, so you don't need to take the rack physically under the desk, of course, but you can just use provider that do this for you. Okay, the price still gets lower. Okay, good. Why I'm telling you this? Not because I'm following the cheapest option, okay, but just to let you know that with the prices different, with the different prices come different level of service, of course. Okay, in this case, the service level agreement. For instance, what is the service level agreement? Is something that the provider, the hosting provider, the cloud provider, commits to you in terms of monetary commitment. So they say, if I go down for more than 4 hours per year, I will pay you like a fee, okay, a compensation fee for the time you've been down. Okay, something like that. With the chip cloud, this is enforced sometimes, as I studied, as I discover in the cloud. In the bare metal one, you should do it by yourself. So if you have a server with two hard drives and one hard drive fails, it's up to you. Hang up the phone and try to contact the support. Please change the hard drive, the second hard drive, the third, the primary one, something sometimes. So it's something that you should build. Okay, so this can be a point where the price cap stands. Okay. Uh, in the network part, with the major cloud provider, I saw in every major cloud provider a huge, plenty of options to configure it, beautiful ways. And of course, more you get a cheap option, more you get limited. Okay, even with the regions, if you want to deploy something in Azure, you have like, I don't remember the number, the exact number, but like 40 locations. Okay, if you want a cheap cloud provider, I tried to study like 4 chip providers. We have a medium, an average of 5 locations. Okay, three to 5 locations. Okay. On the other side, the bandwidth, that is a thing, can be important in some in certain scenarios like mine. Okay, since I work with big data and the movement of this big data raise a lot of bandwidth. Okay, in that case, in major cloud, it's pay per use, but sometimes in the other cloud providers are really flat. So like an included cap that is really high sometimes. This could be seen as an advantage. Okay. Good. Just want to make some assumption. Session is not to point the finger on the public cloud, telling the devil's out there. No, I started cloud native, and I still love the public cloud. Those were my first session in around Azure. Okay, Azure started in 2009, but I started to talk about it 3 years later. Okay, and what I was impressed of was those kind of patterns that at that time was really hard to implement with something that was in cloud. Okay, so if you needed something like on off for an event, or that would grow fast or with unpredictable bursting, because you had an event and then goes down again. Okay, you have like a final of a on a soccer match, okay, something like that. You needed to oversize probably your infrastructure to stay up, and the cloud could be a really good alternative. But what I learned first, and this is my tip number one, is that not every company is a startup. So not every company can work in this pattern. Okay, in the growing fast pattern. So if you are entering a company that isn't using cloud, okay, public cloud yet, and it has a stable usage, okay, probably that kind of hype generated by you go to cloud because it's infinite, indefinite, scalable, okay, it's not so interesting in their opinion. Okay, so think about that. In startup, cloud probably is a must-have, like a no choice. Okay, if you want to run a startup, you will probably go first to cloud. No options, in my opinion. Okay, so this is an opinionated session, of course. But think about that. Not every company is a startup. In my first years of the delivering session, this was my one of my favorite slides. Okay, with this, I want to refresh your thoughts about infrastructure as a service, platform as a service, or software as a service. While here with like on premises, you have to manage everything. Okay, like from the network to the application. More you get, more you abstract, the more you get on the right side, more the platform manage something. Okay, in infrastructure as a service, you just need to deal with the operating system and the application and so on. With the platform, you just deal with application and data, of course. And with software as a service, Google Suite, Office 365, Dropbox, OneDrive. You don't have to deal with anything. You can just use the services, and that's all. Okay. So um, my second tip is to try to focus in your business and your day-by-day routine to the value added services in the cloud, of course, and in the cloud, and in while running applications. Okay, when you run an application, not the code. Okay, apart from the code, which is the value added services that stays under the hood of your application. And what I mean with value, I tried to think about it, and I really think that value is often, but like always, okay, almost always represented by software. What I mean, I want to give you an example. Okay, it's a function. I really would like to ask to you how many of you knows it's a function. It's a function is the serverless offering of Azer that lets you write code write just the code you need to make a task, and then execute it like server in a serverless way in the consumption mode. Okay, but which was the path of Azure Function. Probably now is different because they've rebuilt the platform many times. But in day one of Azure Function was built on previous technologies. So the first technologies of Azure released to the public were cloud services. Cloud services were a technology in, I think, 2009, something like that, when where you could deploy like a web package or a worker package without dealing with machine creation, virtual machine. Just to let you know, Azer at the beginning didn't have an offering about virtual machines. Okay, the first offering was cloud services, storage, and then SQL. Okay, so only platform as a service, because Azer, Microsoft, thought that platform as a service was the future. After that, of course, customers also asked for VMs because Amazon had VMs, competitors Google had VMs. So they needed to face with this opportunity. Okay, and they also provided VMs, but they started with this great idea, in my opinion, to have just platform as a service. Okay, but okay, close this little off topic. On this service, they build like 2013, 2012, something like that, the Azure App Service that was called Windows Azure Websites. That was a really interesting, probably it has been the most interesting platform as a service in the world for years, okay, to deploy web application without any lock-in, without any custom adaptation, okay. You didn't write code to fit Azure App Service. You just write your application in Java, .NET, PHP, Node.js, as you did, okay, before, and deploy to Azure App Service, and it worked, okay. And that service was built on cloud services. So they used a previous technology to build a value-added service. After that, on App Service, they build Web Jobs. Web Jobs is an engine to run. It's still it's still live, okay. So you can really use it today, okay. And Web Jobs is something that can run your workloads, your not user interaction workloads, to do short and long-lived jobs, making some sort of things. We used it to move data. We used it to calls API and something like that. Okay. After that, they thought about, okay, web jobs are really powerful, but we can even release like an SDK to help developers to use better web jobs. So they released the web jobs SDK, and in this SDK, there were some triggers, okay, to react to external events, like if an event arrives from the queue, so trigger this function and output the result to that blob. Okay, so they worked around input and outputs, some sort of orchestration layer. Okay, after that, they realized that the code you should write as a developers reduced a lot, because they built a good boilerplate around it, and they packaged it as a service and they called it Azure Functions. Okay, so Azure Function actually was WebJob SDK as a service. So that's why I really believe that the value added services are the services where a good software resides. Okay, so in this case, uh, here there are virtual machines, of course, and then hardware, but we are paying and we're happy, I'm happy to pay for a value added services that actually is represented by all the software stack. Good. Just to recap, since a VM is just a VM, okay, if in a set of VM we install and manage an Elasticsearch cluster, I can resell it as a search service, okay? It's something really trivial probably, okay, but if we repeat to ourselves, probably we figured out that software is the key to add value to the metal, okay, and even attached storage, okay, if you take two hard drives and and put them into an S, you have a storage array, but if you write some software that abstract it and implement some sort of api on it, you can have an object storage, so you can sell it as an object storage itself, okay. So, coming back to the previous slide, what I want to discuss now is to focus on that part. So, the platform as a service and the software as a service. Why? Because with infrastructure as a service, I start with the assumption that adds not so much value. Okay, if you have a cloud with 99% of infrastructure as a service, you can really switch from a cloud to another without any kind of hassle, just following the good price and the contract and the good deal from you and the sales representative of the cloud. Okay, but with platform as a service, it's difficult because if you have value-added services, it's not so easy to get out in seconds, okay, because they provide you with value, and the other side probably they provide you with lock-in, okay. Just to make you some context around Azure and some great platform as a service that I used in the last 10 years, a few years, I need to mention App Service. I just explained it a few slides um, a few slides ago, but with App Service, you can deploy websites, you can scale in seconds, really seconds. So you can just say from one instance to five, and you have, after like 10 seconds, 5 instances. Okay, why? Because the underlying technology is designed to be stateless, so machines are ready to go and they are configuring in real time. So it's really, really interesting. Please take a look at this. And it's integrated with DevOps. It has web jobs, so really, really interesting. We have something to, I say we because I'm really in love with Microsoft, but I don't work with Microsoft, okay? Azure has Event Hub. Event Hub is something like Kafka, if you know Kafka, and if you don't know it, is like an event platform. So it can handle events, incoming events, and you can spawn it through consumers. Okay. The good things of Event Hub is that it's Kafka compatible. So if you have an application that is using Kafka, you can unplug it, unplug Kafka, and use Event Hub. But it's also integrated with the other services of Azure, and it's even not so expensive, and it's managed, so you don't need to manage anything around services, connection, quorum, and something like that. SQL database was probably one of the first big deal of Microsoft. Okay, as I told you, they released the cloud services, storage, and SQL. SQL was a big deal. Why? Because it abstracted and it managed all the stuff of install, fine tune, and manage a SQL Server installation. Then it provides high level services like point in time restore, backups, scalable and behavior. So you you can change even right now from 2 core to 50 core in a few minutes. Depends of some constraint, but it's very different if you have an on-premise database server. Okay, so really valuable services that I used for years from the beginning to right now. We have Synapse, that is an integrated solution for data management, data engineering, integration. It has a managed Spark cluster, multiple cluster if you want to create multiple. When you can run notebooks in Python and other languages to build your pipelines and your data workflows, we use it a lot. Okay, and it's very hard to get out of it, not because we want to get out of it, but because it's really useful and comfortable for us to use it. Container apps is another interesting thing. One of the biggest problem in the last 10 years is to run your own Kubernetes cluster. Okay, so many people told me, yeah, I'm using Kubernetes, wonderful, because you just spawn a Docker container and that's all. Okay, but after that, you need to manage the cluster, the nodes, the communication, the drivers, the uncharts, and so on. Okay, but with the container instances, you are not seeing any Kubernetes cluster. Okay, it's not the AKS offering of Azure and the EKS of AWS and the GKS of GKE of Google Engine. So it's not a Kubernetes managed where you see infrastructure, when you see instances. It's not mentioned in my platform as a service definition. For me, platform as a service is something where you don't see any infrastructure running. Okay, and that's why container instances and container apps are here, because with container instances you just push your Docker container and it runs without any kind of knowledge around Kubernetes. And that's an identity platform. I don't want to give too much words on that, but too many words on that, but it's something that you should reuse. We are in the 2023. Please don't implement your own identity and authorization management system right now. We have logic apps that are like workflows in a UI based. We have storage. Storage is the foundation of every cloud service. So storage in Azure is called just blob storage, or AZ storage. In AWS called S3, if I remember correctly, and Google is like Google Storage, but I don't know. And we have API routers and so on. That's show reel of platform as a service building blocks was just to give you some context of the greatest technology that I use every day in Azure. But now I want to make a question. Okay, that's should we, so if the reasoning is okay, I'm started to tell you some pitfalls of this approach, and now I'm telling you a great value by using platform as a service, and that's example services that I showed. Should we avoid, so the message is, should we avoid to use to buy platform as a service? My short response is, of course not. Okay, but my third tip is to that we have to learn how the cloud does its own platform as a service. What I mean, now we probably are accustomed with some concepts that 10 years ago were not so common, and we needed to implement multi-tenancy by design everywhere. Okay, always. So probably if you need to build a new app, you don't even think to write to deploy the instance for a client, and then as the same exact code infrastructure for the second client and for the third and for the fourth, etc. You probably have in mind some best practice, and you will do a single deployment for many clients, and eventually you can duplicate this for scalability purposes, but your application will probably react to multiple clients in a single deployment unit. Okay, this is something that is really valid in cloud, is something that is valid actually generally speaking. So something that we probably should do from the beginning of the distributed computing era. Okay, but with the cloud now it's mainstream. So the cloud helped us to learn this concept, and if you're not on track at this, please think about it, because multi-tenancy now is something that you couldn't avoid at all. The automation is another nice, interesting building block that you should deal with. So Terraform started like 10 years ago, something like that. And with Terraform, we discovered and we all implemented in different ways the infrastructure as a code approach. So we write code to describe an environment and then push it to a provider that can be a cloud provider and so on, to automate the resource creation. Now it's not so common to create resources manually and repeating this every time. So this is something that we learn from the cloud. Okay, we also learn to optimize our solution. So as with public utilities, probably your mom, your father, your parents, generally speaking, told you to close the light after leaving a room, okay, because of it's expensive and it's useless and it's wasteful to leave it open. At the same approach we used with public cloud, because public cloud was and is built on consumption of usage. So if you have a machine that is not really used, we can turn it off and free up resources and money. Okay, so this is something that now we have in mind, and we learn it from the cloud. And also the complexity of application. If some one of you have experienced a migration project, so a project that started from an on-premises environment to a public cloud and platform as a service environment, you discovered how was hard to fit every single block into the platform. So probably you tried to simplify your previous application stack to fit the platform as a service. So now with that learning, with that thought, with that reasoning, we are writing simpler application. Okay, good. So that's something that I just discussed, and that's an example of what we can learn from the cloud. This is the app service architecture. I don't know if it's actual, if the current one. This slide is quite old, okay. But at the beginning, the Microsoft told that they had some stateless servers, and the state was outsourced to a single centralized file server accessed by a public endpoint and a deployment proxy. Okay, backed by the blob storage. The state of the deployment was persistent in a SQL database, and the front end was scaled with ARR, like a reverse proxy of Microsoft, that's called IIS, and a load balancer. Okay, this is a great design. Okay, probably now it's evolved and evolved again and again. And with this in mind, we can even implement our own stack with this approach. Okay, with the farm approach, with the enterprise approach. So if you learn how to do this, and 10 years ago was really hard, okay, but now it's not so hard. So if you understand how to do this, you can create that value, okay, by your own, by yourself. Okay, this is how it's built. The new offering of SQL database is called Hyperscale. Okay, it's really hard, but just to give you an example. And this is the reference architecture for Azure Kubernetes services that you can take that you can see and watch to take some insights and some reasoning. Okay. My third tip is that state is the real game changer. So if everyone can outsource their stateless workloads, so the code that executes the web application somewhere. Okay, if you run this application in Azure, in another cloud provider, in your hosting provider with a public faced router, probably you can make your day. Okay, but if the state is saved locally, so on your machine, on that cloud provider, on that single machine that executed your workload, in case of a failure, everything is lost. Okay, so probably the first reasoning is, where should I keep my state? And that's why state is the game changer for your choices, because where the state is probably is your main single source of truth. Okay. And another question: do we know how much is the cost of a terabyte? I this was harder to estimate. Okay, so I proposed this table because the assumption is 10 millions of files with a total size of 1 terabyte and with some options, so frequent access, infrequent access, and long term. There are those are similar offering for every public cloud providers. So you see that they change. This is really unfeasible. Okay, of course, but in these cases, the cost can be a lot compared to what you pay for 1 terabyte and transaction in a local environment. You can say, yeah, but in your local environment, you don't have APIs to access it. So transaction stays because they add values, of course. And that's why I think that value is around software, not, of course, the slice of storage that they are selling to you. And on top of this, if you have 1 terabyte of data, 10 million files, to get them out, you should even pay, because you should pay for the reading part, the extraction part, and even for the bandwidth. Okay, if you are in the public cloud. So think about it. And this is the principle to introduce you the tip number 5, that is lock-in. Identify the lock-ins. Lock-in is the principle that mm, attach you to a provider with some great features or great constraints. Okay, and uh, let you go out with some difficulties. Okay, so you can discover lock-ins while you are getting out from a service, if it's really hard. When a service is so complex to manage that you say, okay, no, I just don't want to go out, because manage Elasticsearch, Kibana, Logstash environment is too hard, so I want to pay for a managed installation and that's all. Or because you had to make some custom implementation to fit to that platform as a service. For instance, because that service required to you to write a specific code, write a wrapper on your application. So your reasoning is, well, I invested a lot to fit on that path, so I don't want to switch it back, okay, and go out. Or because the solution is unique. So until for the last no until 2 years ago, 1 year ago, the container instances that I mentioned before, so serverless containers running without any looking into Kubernetes ecosystem, where was unique to Azure. Now other cloud provider has it. Okay, so in that case, if you want that unique solution, you should go with a cloud provider. Or you are locked in because you are using plenty of service that cost so not so much, okay, that it's a pity to invest to get out of them, and that's usually a good thing. Okay, because if the value added is so high and the cost is so low, even if they are many, you should probably focus on them. And that's why I created this pyramid, where I suggested to try to be locked in only the vital many services that are not consuming the much of the budget. So this is my personal Pareto rule, that in my opinion, few services run the 80% of the overall budget. So we should focus on those ones. Okay, try to reduce our money footprint, okay, our consumptions, and to rationalize our infrastructure. Okay, I would suggest to build your own path if you can, or please try it, because it's a good reasoning. You can learn a lot of stuff. You can learn to optimize. You can learn how the cloud provider reason, and you can really have a great step up in your organization if you try to do this. You can start by identify some services like the storage and ask to yourself, uh, the storage that you're using is your primary storage, because if your primary storage is the single source of truth, so you don't want for any reason to lose data on it. Okay, but if it's not the primary storage and you don't even need the high availability, just a copy. Okay, and the scalability, yeah, required is I don't know, 10 calls per second or something like that. It's really needed to have a service that is hosted with great service level agreement and so on. And with the database, some questions stay, but you can also ask yourself how much. Well, it's easy or not to set up and tune the software as in the public cloud offering. Okay, because if it's easier to get on track with a good installation, okay, that's a path behind with the medium complexity. But if it's hard because the premium offering is really hard to achieve, so it's not so easy to get in that direction. And which is the overall cost, the total cost of ownership of this solution. And after that, the last one is provocatory. Do we really need an RDBMS today? So we are using an RDBMS because we really need it, or because we are accustomed to use tables to represent our data, but we can use even other technologies, okay, like NoSQL, for instance. But even for NoSQL, stays the same. If you use Redis, for instance, you probably installed once in your life Redis on a server, on a standalone server, and you will probably discover that it's a software without so much issues. Okay, it's a cache, and so by design, it's something that should not keep their state. Today, it's a different thing, but when I started, it was just a cache with some few messaging option. Now it's a cache, a messaging broker, a state machine, and so on. But if you use it as a cache, you will probably think about it as something ephemeral with no longer term picture. Okay, and you can probably implement by yourself because state, that in my opinion is the game changer, is not really involved. Okay, so this tip is provocatory, is try to focus on the enhanced MTTR. So the mean time to repair can be mean time to restore or rebuild. Okay, so you can think about how is hard to get on track with SQL, with MySQL, with MongoDB, with Redis. Okay, I need some learning curve to install it and fine tune. And after that, if you have some problem and you need the fine tune to investigate on it, or the system breaks down. Okay, how can we proceed to fix the existing installation, or to start from scratch with a new installation, how many times happened that you had a machine blocked in cloud and you just restarted it, or you just scale up and down to have thing fresh again? Under the hood, a machine was destroyed and another one was provisioned and put the state onto. That's the same thing I'm suggesting you to do, to automate all the process to recreate your resources in the fastest way possible to get on track again in minutes. Okay, so this I have not so much time to finish my slide, but it's okay because I'm telling you the concept that I wanted to tell you. One of my last tips is to buy something you really need, not in the case you need it after a week, after months, okay, but if you really need now. And that's why it's important to focus on the business, the application need, and not the contract. So don't let sales representative sells you the whole picture if your picture right now is small. Okay, so try to focus. Of course, it's something can sound trivial, but it's really actual. I didn't mention some services to investigate on because they are usually services. They are I say cheap, but I would say not so expensive. Okay, networking, identity manage, they are not so expensive to make a reasoning around them to say, okay, let's save some money, implement them by your own. Good. A nice thing if you're using Azure is to use Azure Arc. That's a control plane that you can integrate in your external ecosystem. So on-premises, Kubernetes cluster running everywhere, even in other clouds, to get a single unified views of all your resources. And that's another interesting thing, that if you extend any CNCF certified Kubernetes cluster, you can even use Azure Arc to inject application stack from the Azure part. So since we can, of course, integrate SQL Server instances, virtualization technology, servers, simple servers, with the Kubernetes option, we can have overall a central point of administration extension. We can inject, of course, in the cluster some sort of logging technologies without any knowledge of Kubernetes. And after them, we can even build some Azure services inside our Kubernetes cluster. So just to let you to let this clear for you, you can have a Kubernetes cluster running on your local machine. Okay, you can install Azure Arc, and from Azure you can deploy app services. So you can run platform as a service in your local machine, and as you can do in your local machine, you can do this everywhere. Okay, uh, don't forget the bandwidth, because it's a cost that if you have multi-cloud and deploy and your infrastructure is deployed in multiple locations, something that you should deal with. And if you follow my session of yesterday, you probably know that I'm a fan of environment. So take a look at the Green Software Foundation, because this approach that I'm telling you today is something that can be effective, but it's something that can be opposite to the sustainability, because the cloud providers really invested really a lot on environment, while with hybrid workloads it's not so crystal clear. Well, thanks to be there, and I leave you some references for you. And since I'm running out of time, thanks, May, I just want to ask you to reply to a question if you have it. Otherwise, thanks so much. And you can reach me out on GitHub if you have any question. Yeah.
Okay, so thank you so much for your talk. It was very interesting. I think it's super relevant for, I want to say everyone, but I don't want to speak, for anyone else. I'll say it was super relevant for me. And we only have like 1 minute left. So, I want to ask you, I want to see, like, I don't see that we have any questions in the Q&A, but in this entire session you didn't tell us what you think. Like, what is your personal opinion? Like, what would you do?
Yeah,
uh
yeah. It's a good question because I don't want to suggest to go in a way or another way. So use only the cloud or use only on premises. I want to pass the message that after several years in the public cloud, I realized something that I never realized before. That now hybrid can be something that can be used and implemented by not few like in the past, by the many. So you should think about it. You should try. You should try to even offload some of your workloads
right.
of the cloud and try. And it's
Okay.
quite easy in
Yeah,
some certain situation. Yeah.
totally. Okay, thank you so much, and thanks for
To you.
everyone who joined. It was great to have all of you here, and that's it. Bye.
Thank you.
This is all we got. Remember the revolution in our minds. This is all we got. Lock me out of this life institution. I am angry and I on illusions. Yes, I hate, but it's not a solution. Try my best, buddy, I'm just a human. Oh, we don't